We're going to start our discussion of succession today by looking at this bare mineral environment that is so typical of the seashore. The kinds of conditions that you find at the ocean are rather good at preventing land plants from getting themselves established, and so they remind us of the kinds of places where primary succession begins. If you look at the top of those limestone cliffs there, you can see a little bit of green on them, and that actually is plants starting to colonize that location, even that close to the ocean. If they're that far above it so that about all they're getting is salt spray, then higher plants can begin to colonize. We began this topic of succession at the end of our last video, and today we're going to investigate it in quite a bit more detail. And we'll start that investigation by making some definitions. We're going to be seeing that when we look at succession as it occurs in plant communities, that there are often recognizable stages that go on for a while, sometimes years, sometimes decades, and sometimes even centuries. And these recognizable stages are called seral stages. When a community reaches a steady state, that is, a state at which it is self-sustaining, the kind of species that are present pretty much stay the same over time. They replace themselves as they age and die. Then that we refer to as a climax community. The photograph on the upper left illustrates a climax community that can be found in forested regions across northeastern North America. These are old-growth yellow birches that occur in the Adirondack Mountains of northern New York. And in this area, the climax forest community includes species like yellow birch and eastern hemlock and American beech and sugar maple and several other species that are very good at reproducing in their own shade, and so they retain their presence in these environments over long periods of time. Within the primary successional sequence, we can recognize two types. The kind that occurs in uplands is referred to as xerarch succession, and that's what you see going on in the upper right hand photo on this slide. We have a bare mineral environment which is being colonized by some of the first kinds of plants that are capable of establishing themselves in this kind of an environment. In the lower right-hand picture, we're seeing what we can call hydrarch succession, that kind of succession that occurs in wetland areas. So let's look at some examples of these kinds of situations. Let's start out with a classic old-growth community, the redwood groves of Northern California. These systems have predominantly one species of tree in them, the coast redwood, and this species attains very great age within these systems. They can live for well over 1,000 years, and in fact these trees you're looking at here are in that range of age. In the fog belt that develops along the coast of Northern California, this rather perpetually damp kind of an environment with a mild climate throughout pretty much the entire year, this one species tends to come to predominate, and in locations where it does, it persists for many centuries. in this self-sustaining kind of an environment. Now, we can also see very different kinds of climax communities. However, let's take a look at a very different kind of a situation. Even within forested environments, trees don't necessarily have to become gigantic in order to develop into a climax community. And that's what we see on the peaks of the Berkshire Mountains in western Massachusetts and even into northwestern Connecticut. So this peak we're looking at here is vegetated by a community of rather straggling low kinds of trees and shrubs. Let's take a closer look. What we see here is a community of pitch pine, and in the individual that you see here is not much more than about 6 or 8 feet tall, and some bare rock right at the summit of this mountain, and primarily an area of shrubby growth. Much of that shrub growth is of a species of oak called scrub oak, and then scattered about there are other small kind of shrubby species. But we would normally not think that this would be a climax community. It looks kind of like an area that's young and still developing. However, when one actually takes a close look at these trees in here and takes a core of them, actually drill a hole in one and pull out a core of it and take a look at it, these little trees are centuries old. In fact, ecologists were surprised when they actually went out and took a close look and discovered that they were centuries old. So what we see here is a community that, because of the environments of these mountaintop peaks, has established itself in a condition that looks like a young community, a developing community, but which is one that actually is steady state. In fact, these communities have probably looked about like this on these mountaintops for the past 6,000 years. Although, if we look carefully about, we can find members of a community that even were present before that time. If we explore around among the bare rocks, we can find this plant, for example. This is a little relative of the rose, the same family as the rose, called Potentilla tridentata. It is a species that is characteristic of the Arctic and probably colonized these mountain peaks not long after the end of the last ice age. And so its ancestors have been growing on these peaks for the better part of 12,000 years. And while the community overall has changed, certain species from that earlier time have been able to persist. Now, again, these kinds of processes that result in bare mineral environments developing into climax communities and uplands, these kinds of processes are referred to collectively as xerarch succession. Now let's turn our attention back to the idea of hydrarch succession. We're looking here at an Atlantic white cedar bog. This is an environment that develops obviously in a wetland environment. We find them from eastern Massachusetts, eastern parts of New England in general, all the way down the coastal plain of eastern North America. So these are environments that develop in low nutrient, rather acid kinds of ponds, and they colonize the surface of the water of these ponds and grow out over it. And so what you're seeing here as you look from right to left is the oldest portions of the bog with trees, these Atlantic white cedars, and toward the left, the youngest portions of the bog that are still growing out over the surface of the water as roots and stems project out over the surface. And so in these areas you tend to find herbaceous plants and low shrubby kinds of things. From one year to the next, dead plant remains accumulate on these bog mats, as they're called. And as the thickness of those plant remains becomes greater over time in the oldest parts of the bog, then larger kinds of plants like trees can become established. They can set roots in these remains, this stuff that is referred to as peat. The youngest parts of the bog with the thinnest layer of accumulated debris can only support low kinds of plants. Let's consider this idea of primary succession a little bit further, specifically as it relates to the kinds of environments that develop here in southern New England. Now, we've seen that in places like the Berkshire Mountains, areas of bare rock are initially colonized by low kinds of plants, some of which have remained on those mountain peaks ever since their initial colonization. Also, things like lichens and algae and mosses colonize these environments, and as they colonize them, they're changing that environment. The production of organic acids by these plants can start dissolving the rock, and once that happens, then you have, over a long period of time, the development of soil. When you get little pockets of soil and crevices in these rocks, then larger plants can start becoming established. Of course, this is a very slow process, and it's one of the reasons why these Berkshire Mountain peaks still have vegetation that looks like early to mid-successional kinds of vegetation. But let's look at this image at the bottom of this slide here and consider what's more typical for lowland areas. Along about 17,000 years ago, the Ice Age in southern New England was coming to a close, and ice was retreating from across this region, with areas on the present coastline being ice-free first, and this Berkshire region retaining ice the longest. Now, once that ice did melt, however, you were left with a bare mineral environment, which could then be colonized by, again, these low kinds of plants. So we might find things like mosses, and even things more primitive than plants like algae and lichens and fungi colonizing these surfaces. And once they colonize, as they change their environment, adding nutrients to it, dissolving out some of the minerals that were present, releasing nutrients in those surfaces, and also leaving dead remains, then other kinds of things could start to come in. So then we might expect to see low herbaceous plants like grasses and forbs colonize the area. A meadow kind of a stage become established. In this case, it would have been rather like tundra in the vicinity of 10,000 years ago in our landscape here. Then, as soil developed, as organic matter became accumulated in the soil, then we might expect to start to see other kinds of plants colonizing, larger plants. As the climate warmed further, we might expect that various kinds of shrubby, woody kinds of species could then become established. These are the so-called pioneer woody plants. And then for several thousand years, the forest type that would have been established in southern New England would have been spruce fir, much like you find today in northern New England and Canada. These kinds of trees would have prospered in the still cool environments that would have been present. But then, along about 6,000 years ago, the climate warmed to the point where the spruces and firs started dying out, and they were replaced by forest types that are very similar to what we still see today. Forests dominated by things like oaks and hickories and maples and ashes and all of the typical kinds of northeastern North American deciduous trees. Now let's turn our attention to secondary succession. Now, in looking at this photograph here, you might be thinking, well, this looks like an old growth system, and so isn't this the ultimate result of primary succession? Well, yes, it would be if a system were left undisturbed in the northeastern part of North America. We might find a situation like this. But actually, this particular stand is a consequence of disturbance that happened on the site a long time ago. Human disturbance, in fact. Back in the 1700s, this area that we're looking at was logged over and might have even had some agricultural uses by colonial farmers. However, about that time, sometime in the mid to late 1700s, the area was abandoned. And this open landscape provided a perfect ground for germination of eastern white pine. Eastern white pine likes to germinate and start growing in bright sun. It doesn't have to, but it often does. And so when an area is logged over, white pine in parts of the Northeast, notably the Berkshire Mountains again, can become a species that colonizes heavily. And so what we're looking at here is the ultimate result of that. White pines that became established in the 1700s are now very big trees. One of the things about white pine is that it is a rather long-lived species. And so once it becomes established, the shade that it generates with its evergreen needles creates an environment that largely keeps out other species. And so they can stay predominant where they've come in after disturbance for centuries. Now, also, however, this particular stand did have some human help. People have been going in to this stand for probably the better part of 200 years and thinning it. And by thinning it, the trees that were left grew much more rapidly. By opening up the forest, it allowed these trees to escape the competition of neighbors growing too closely. And so they developed these very wide trunks. And they also grew very tall. A lot of these trees are in the vicinity of 150 feet tall, which is quite large for eastern North American trees. And so actually by doing some forest management here, this is a much healthier stand than it might have otherwise been. If it hadn't been managed, the trees would have been thinner trunked, even though they still might have grown very tall, and would have been very susceptible to storm damage. Now, as I said, eastern white pine does like to come in after an area has been logged over or cleared in some kind of a manner. It does well germinating in these kind of soils that are exposed to lots of sunlight. However, it doesn't have to do that. We see white pine saplings here invading a stand of oaks in southern New England here. So it is capable of competing even when there is some shade. But again, it depends on the particular environmental conditions. It is more of a northern tree, and so in cooler, more northern kinds of environments, it has a competitive advantage that it starts losing as we get towards the coast of southern New England. Now let's take a look at a typical kind of a secondary successional sequence as we might see it in northeastern North America. We're looking here at my own property, which when I bought the property was covered with a stand of young trees. I wanted to use this portion of my property as an orchard, so I logged off all those young trees and then turned over the soil here. So I pretty much brought it back to a mineral soil kind of a situation, not sterile mineral soil by any means, but an environment in which a lot of bare earth was exposed. Then the following year, this is what I got. What we're looking at here are what are often referred to as annual weeds. Actually, many of these are not annual, but biennial, which means that they come up for 2 years. Annuals are plants that come up 1 year, set seeds, and then die. These are typically the kinds of things that colonize an environment that's been so thoroughly disturbed like what I did. Annuals and biennials come in. So we're looking here at Queen Anne's lace, which is actually a Eurasian species, and also our native black-eyed Susan, which is a native prairie plant that also occurs over much of the Northeast in any kind of disturbed situation. Now, one of the things about these annual weeds is that they tend not to be very good competitors with certain other kinds of plants, like perennial plants, plants that can come up from their own roots every year. So generally speaking, after a couple of years, the environment that we saw in the last photograph would evolve into one that looks more like this. This is an area that's dominated by perennial grasses. It gets mowed every year, so now that these perennial grasses are established, it stays in grass, but this environment is the one that replaces the previous one over a period of several years, and then this becomes the dominant community for another few years, and if it's not mowed, it also starts to be replaced. In the absence of further disturbance, such as mowing, woody plants will start to colonize, especially certain kinds referred to as pioneer woody plants, species that like to come in bright sunny situations where the soil has already been modified some by the plants that have already become established. They start providing organic matter getting mixed in with the soil and things like that. And this species that we see here, eastern red cedar, is a classic pioneer woody species. It can actually live to great age, although more typically it might live 20 or 30 years before it gets again replaced by something else. Now, eastern red cedar we find as a predominant species in milder locations. So here in southern New England we find it predominating towards our coast, but as we get inland to more mountainous locations, the pioneer woody plant is often white pine, as we've seen previously. Lots of shrubby species can also become established at this stage, not just tree species. This stage in succession is often referred to as the old field stage, by the way, because it was once a field and it's now been colonized by other kinds of plants. After about 20 or 25 years or so, the old field then gives way to an environment that looks more like this. We have numerous young trees that have become established. In fact, this species right here is one of the ones that often comes in. This is white birch. Its cousin gray birch is another commonly occurring species in these young woodlands that overtop the old field. White birch we find particularly again in more northern kinds of areas here in New England, and gray birch is more common in some of the more southern coastal kinds of areas. But they form these stands of thin-stemmed trees that are often called by foresters pole timber because you can cut them down and use them for poles. Often very dense. Often they'll all start growing at about the same time, so they can be referred to again by foresters as dense, even-age stands of trees. And then, as we saw with the white pines, these dense stands of trees start competing with each other, and some of the trees start dying, and eventually the characteristic of the forest starts to change still further. So let's look at what typically happens next in southern New England again. Especially gray birch tends to be a rather short-lived species, and it gets overtopped by species like these, oaks and hickories. And so the characteristic of the forest changes again from that pole timber stage to one that starts resembling something more like mature forest. Although, as you see here, these trees are still rather small and might be 20 to 50 years in age in this particular stand here. If you notice on the left, lower left part of this picture, there still is a little bit of green there. Those are actually some surviving eastern red cedars that haven't been completely overwhelmed by the oaks yet. Now those young oaks don't stay young, however. Over time, those slender trunks become big trunks like this one here. Oaks tend to be rather long-lived trees, and so once they've become established, they can predominate in a stand for at least a century, and sometimes more than that, depending again upon local conditions. This particular tree here is a red oak, a widespread species in northeastern North America, particularly in cooler environments, and it can live to be 200 and 300 years old. Now, given enough time, even these oak forests will start to change. Oaks do not reproduce that well in their own shade, and so over time they tend to decline in abundance in forests. And that is actually what we're seeing now in southern New England, is that our oaks are starting to decline in density in our forests, and they're being replaced by species that are more shade tolerant, species that can reproduce in their own shade, like eastern hemlock and American beech and yellow birch and sugar maple and several other species as well. These are the kinds of species that are now starting to assume dominance in our southern New England forests. In fact, our forests are looking more like what the Pilgrims would have seen centuries ago than they have since that time. Our forests are actually approaching old growth conditions in many instances, even though we have a very active logging industry here. The aging of the trees is outstripping loggers taking them from our forests, in many locations at least. And so as forests evolve in this direction, we are now reaching conditions that we could refer to as a climax community for much of southern New England. So we can summarize these kind of patterns like this. At some point in the past, perhaps in the mid-19th century, when farmers were leaving southern New England in droves to move to the Midwest, the farm field was abandoned. It was then colonized by annual and biennial weeds, forming a weedy field stage, which lasted for a year or two, and then as perennial plants became established, it would have looked like a meadow for a few years. In the absence of further disturbance, woody plants would have started to colonize, and that area would have become an old field, still with those meadow grasses, but punctuated with pioneer trees. These trees would have increased in density, especially certain species would have colonized, and the area would have undergone, after about 25 years or so, a change into a pole timber stage with lots of young, slender tree trunks. Over time, some of these trees would have died, the forest stand would open up, and other species would colonize that, reproduce in that shade. Oaks, in particular, in southern New England would come to predominate. Many of them might have actually become established in the old field stage, but because they're slow growing, it wouldn't have been until about 50 years that they would have become a noticeable component of that forest. Then, over the next century to a century and a half, oaks might predominate until eventually more shade-tolerant species start replacing them. And at this stage, when left alone, we see the climax community developing. Now, there still are actually a few more things that I want to say about succession, but this is where we will end for today, and we will pick up with this topic again next time.